Have you ever been on a bus and felt like you're being tossed around like a rag doll? Or, tried to push a really heavy sofa and it just won't budge? Well, it turns out there's a hidden rule of the universe that's behind all of that. Today, we're pulling back the curtain on the physics that secretly runs your life, Newton's first law. Seriously, just picture it. You're standing on the bus, maybe not holding on as tightly as you should be. The driver suddenly hits the gas. Your feet move with the bus, but what does the rest of your body do? It feels like it gets thrown backward, right? So, what's going on there? What is this invisible force messing with you? That feeling of being pushed and pulled, it's not random at all. It's actually a clue. Let's call it the bus jerk puzzle. And trust me, once you solve it, you unlock one of the most fundamental laws of how everything in the universe works. I mean, think about all the ways your body seems to fight the bus's every move. When the bus takes off, you're thrown back. When it slams on the brakes, you lurch forward. And when it takes a sharp turn, you find yourself practically plastered against the window. Each one of these feelings is a key piece of our puzzle. So who gives us the answer? None other than the man himself, Sir Isaac Newton. He came up with a rule that is so simple, yet so powerful. It explains everything from that crazy bus ride to how planets stay in orbit. So let's break down what he actually said. Okay, I know that sounds a little textbooky, but here's what it really means. Objects are, well, they're kind of lazy. If something is sitting still, it wants to keep sitting still. And if something is already moving, it wants to keep moving in a perfectly straight line at the exact same speed. The only thing that can change that is an outside force giving it a push or a pull. Now this laziness, this tendency for objects to just keep doing whatever they're doing, it has a name. And it's the secret password to understanding all of this. The name is inertia. So inertia is just an object's built-in resistance to changing its motion. You can think of it as a kind of physical stubbornness. And here's the real aha moment. An object's mass is how you measure its inertia. A heavy bowling ball has way more inertia than a light tennis ball, right? That's why it's so much harder to get rolling and so much harder to stop once it is. More mass means more stubbornness, more inertia. And this whole inertia thing really comes in 3 different flavors. First, you've got inertia of rest. That's your body wanting to stay put when the bus suddenly lurches forward. Then there's inertia of motion. That's you continuing to move forward when the bus suddenly stops. And finally, inertia of direction. That's you wanting to go straight when the bus turns, making you lean to the side. It's all just your body resisting change. All right, so theory is one thing, but seeing is believing. Let's look at a super simple classic experiment you can literally do right now to see inertia for yourself. Here's the setup. You take a glass, put a flat card, like a playing card or business card, over the top. Then you place a coin right in the center. Now for the fun part. You're going to flick that card straight out from under the coin, as fast as you can. What do you think is going to happen? Does the coin go flying with the card? And bam, the coin drops straight down into the glass. How cool is that? It works because of inertia. The coin was at rest, and its inertia wanted to keep it at rest. You moved the card out from under it so quickly that the coin was just left hanging there for a split second before gravity said, "Hey you," and pulled it straight down. This is the exact same principle behind that crazy tablecloth trick you see magicians do. It's not magic, it's physics. If you yank the cloth fast enough, the inertia of the plates and glasses, their stubbornness, keeps them right there on the table. They resist the change. So, inertia is way more than just a cool party trick. It's actually a fundamental concept that engineers have to deal with all the time, and it has a massive impact on our technology and, honestly, our safety. I mean, just look at this. The entire reason a seatbelt exists is to fight your body's inertia. In a crash, the car stops, but your inertia wants you to keep going forward. The seatbelt provides that outside force to stop you. Or think about satellites. They just keep coasting through space because their inertia keeps them going, and there's nothing out there to slow them down. It's literally everywhere, from the suspension in your car to a satellite in orbit. So, is there a simple math way to think about this? Absolutely. If the total, or net force, on an object is 0, then its acceleration is also 0. In other words, if nothing is pushing or pulling on something in an unbalanced way, it's not going to speed up, slow down, or turn. It's just going to keep on doing what it was already doing. Now, this is the part that messes with our brains a little bit, because on Earth, we're constantly fighting against things like friction and air resistance. We think you need to constantly push something to keep it moving,
But that push is only to cancel out the friction. The truth is, an object doesn't need any force to keep moving, it only needs a force to change its motion.
So if you take one thing away from all of this, let it be this. Force doesn't cause motion. Force causes a change in motion. And what's the word for a change in motion? Acceleration. That right there, that's the absolute heart of Newton's first law. So we've cracked the code for what happens when all the forces on an object are balanced and everything is stable. But what happens when a force is unbalanced? What happens when you actually push on something and it does change its motion? Well, that is a fantastic question for next time.